Hello and welcome. In this video, we will see how to approach to find the domain and range of quadratic polynomials of this form, square root of ax squared plus bx plus c. See, if I have a quadratic function f of x is equal to ax square plus bx plus c, and if the roots of the polynomials, if the roots of the polynomials are alpha and beta, or we can take directly an example that is better, I think. So if I have f of x is equal to x square plus 5x plus 6. So here a is positive and the roots are x is equal to -2 and -3, you can verify. So if a is positive and if the roots are -2, -3, the curve, how does the curve look? The curve look upside like, so this is my -2, sorry, this is -3 and -2. The curve would look like this. The curve would look like this. It goes up because a is positive, and we have some minimum point here. This we call as f minimum. The range is from f minimum to infinity. Similarly, if I have a curve which is f of x is equal to -x square plus 5x plus 6, then here a is negative and the roots are -1 and 6. You can verify it. Since a is negative, the curve looks down. Curve looks down like -1, 6. Curve looks down like this. It attains some maximum point here, f max, and actually this is f max. From here it goes up to -infinity. So this is how a curve look whenever a is positive and whenever a is negative. So now what we are trying to do is we are trying to put f of x, the quadratic polynomial, inside a square root function. So what if I take, in this case, if I put x square plus 5x plus 6 inside a root. So we know that square root of any number is always positive. It is always greater than or equal to 0. It cannot take negative values. Take any square root of any number, it is not negative. So if I put square root to this whole function, the negative part will vanish. So there will be no negative part. There will be no negative curve. So curve would look like this now. Now for this, curve would look like this. So if I have the roots -3 and -2, the curve would look like this. So it is from here, it looks like this. It never comes down the x-axis. So this is what happens when you put square root. Similarly, when you put square root function to a down looking curve, which is -x squared plus 5x plus 6, so this negative part will get truncated. Now the curve would look like this. Now the curve would look like this: -1 plus 6. The curve would look like this. It never comes down below x-axis. So what I'm trying to say here is, if we have square root of ax squared plus bx plus c, then the domain of this function, then the domain of such functions, the uplooking function is, you can clearly see the curve exists from -infinity to till this root, and from this root to all the way to infinity. We don't have any curve over here. So the domain of such function is -infinity to minus infinity to the root, we can take minus 3 here, and minus 2 to infinity. There is no domain. The domain doesn't have this interval, which is minus 2 to minus 3. So you can write the domain like this, and the range for this function, is 0 to infinity. It is looking up, so it is from 0 to infinity. When you come to this function, when you come to the down looking function, the domain, you can see the curve does not exist. The curve only exists between 1 and 6. It does not exist anywhere except minus 1 to 6. So the domain of these functions will be, for down looking square root quadratic polynomial, is it is from minus 1 to 6. And what is the range? So this is very important. The range of this is it attains some maximum point here. So f max and goes down to 0. So it is, the range is always, for down looking square root quadratic polynomials, is f max to 0. How to find f max? We know the formula, square root of minus b square by 4a plus c comma 0. So let us find minus b square by 4a plus c somewhere here. Minus b square is minus 25, minus 4 plus c is 6. So we have already done this problem, which is 49 by 4, which is 12.25, I guess. This 12.25, let's see. So now let us go to our graph plotter and verify this. So we have two functions here, as you can see here, x square plus 5x plus 6, which is an up looking curve, x square plus 2x plus 3, I'll take x square plus 5x plus 6. So this is a curve which is a down looking curve, and attains maximum point and comes to 0, like this. Now what I'm trying to say is, if I try to put square root function, if I try to put this quadratic polynomial under square root, I'm telling that the negative part of the wave will get truncated. sqrt of square root of, so you can see, okay, x square plus 5x plus 6 square plus 5x plus 6, you can see the curve starts from 0, goes all the way to infinity, and it starts at minus 2, goes to 0. Let us put square root to this function. So this attains a maximum point, x square plus 5x plus 6, and it goes to 0. So we're getting 3.5. We'll see why it is 3.5. Okay. So this is actually square root of 49 by 4 under square root. So which is so minus b square by 4a plus c is 12.49 by 4. So this I have to put under the square root. So this is actually square root of 49 is 7, square root of 4 is 2, 7 by 2 to 0, 7 by 2 is 3.5 and 0. So you can see this goes to 3.5, maximum goes to 0. The next video will solve problems on this type. Thank you.